So welcome with an applause. She has just flown in from London to step in, Jutta Steiner of Parity Technologies.
Thank you. Yeah, so thanks for the invitation. I'm sorry Gav can't be here. He's unfortunately quite sick. So I've been working with him for the past 3 years on different projects in the blockchain space, starting with the Ethereum project that I'm going to talk a little bit about, and now very recently in this company that we started 1.5 years ago called Parity. So just to give you a bit of background, like what I do, where I come from, how I came into this. So I'm a mathematician by training, did my PhD, stayed even for a postdoc, left academia then, worked for a couple of years for McKinsey, felt a bit frustrated at some point, and then started exploring like what's out there in the tech market, and came across Ethereum just by accident at a tech meetup in Berlin about 3 years ago, and then found this concept very interesting, didn't understand very much, but joined the team and worked with them to get this new blockchain off the ground. So yeah, here I am now, a co-founder of a company, which I never imagined, but so's life. Okay, so what I want to do, basically I want to use the time and talk in 3 parts about blockchain, or different aspects of blockchain. So first I want to start with a bit of background about like why it is that we believe it's going to be so revolutionary, then explain a bit more in detail what it actually is, how it works, how we think, or what we think these days a blockchain is, which has dramatically changed over the 2-3 years as well that I've been in the space. And then give a bit of an outlook on where things are heading, what this could mean, especially for the financial sector, but which is just one of the sectors that we think blockchain will have an impact on. So maybe a quick show of hands, like who thinks they understand blockchain? Okay, a few people, not too bad. So let's start with a quote. So Buckminster Fuller said, "You never change things by fighting the existing reality. To change something, build a new model that makes the existing model obsolete." So that's basically the standard or the benchmark from where we want to start. So he suggests if things are going to be revolutionary, then you can't do this just incrementally. You have to do something substantial. And I want to argue that blockchain is indeed changing something in a very dramatic way, from a trust-based model where we have to rely on basically promises that we don't know whether they will be kept, to something where we have tools that we can use in order to have more confidence in how things are going to turn out for us. So what's the current model? Like, what is it that Buckminster Fuller is talking about? Does anybody recognize these institutions? I call them institutions in a very general sense. So there is the casino in Monte Carlo. There is like a modern institution, or maybe not that modern anymore, PayPal. It's already also quite an established institution. There's the UK Land Register here, the stock exchange, and who knows what this is? Anybody? The Lehman headquarters. So yeah, a gone-by institution, I guess. So what do I mean by an institution? And I'm trying to be like, yeah, I'm a mathematician by training, so not an economist, but I have my own kind of model that I'm proposing to you, what an institution is. So an institution basically, or they all share basically 3 different services that they offer in one way or another to people or other organizations that interact with them. So they check authenticity of incoming messages, basically. They check whether you're the customer you're supposed to be. They do KYCing, whatever, in terms of banks. But other institutions do this as well. They do some sort of record keeping, obviously, for the UK Land Register, but also, obviously, for banks. And then they all do some sort of processing, which is represented by the abacus. So this is my very high-level model of an institution. And institution in a very general sense. So it could be a governmental institution, could also be just like an extension of the government, could be something like PayPal, something effectively that we interact on a trust basis. And here's what is basically missing to this model. It's all these three things is what they share in common, but an important thing which is kind of missing in this very mechanical model is because they are all dealing with some scarce resource, could be money, could be other pieces of wealth, they all manage contention because all the people that interact with them have competing interests over these scarce resources. And in the end, it often comes down to a very fundamental thing that we call trust. So what we've come up with over time, in order to give these institutions a way to manage the contention, is we've given them authority. So they are either themselves or maybe like a second-order institution looking over them, have in fact in the end the authority to decide who owns what, how things have to be. They manage the contention due to this authority that they were given. So by extension, we get this four-system model, so little Cartman, the message checking, the abacus, and the record keeping. So yeah, this is our old model. All these institutions basically interacting with each other, not trusting each other often or usually, but being kind of their own, the master in their own universe. So now what has happened over the past 40, 50 years is digitization has changed things quite dramatically, often led to a lot of efficiency gains. So I took three examples to show you what I mean by the digitization of these three services I talked about earlier. So there's the hard drive, which essentially has replaced the record keeping in some ways. There's the chip, which has replaced the abacus. So processing of transactions has become much more easy. And then there's the elliptic curve, so a very modern way on the internet to check authenticity through cryptography. So all this basically comes these days in a very handy way in personal computers, on our desktops, and whatnot. But what it effectively still meant is that we live in a model of walled gardens. So all these institutions sit there and have their servers that digitize all these other processes very much shielded from each other. They don't trust each other, and there's no way of really free interaction between these different systems. So what if we could somehow knock down these walls and like end up in a very magical commons where like rules are kind of automatically built in. We don't have to enforce them. Like we don't have to give this magic authority to somebody, but it's like baked into the way the system operates. And I'm arguing that this is basically what the blockchain has brought us and that we already have such a system. So it makes out of many things just one system where little Cartman just kind of as a spirit sits in there. So I have to give credits to Gav for this little piece of art. So that's the new model. Like a system where rules by design of the system, of this computer system, of the protocol, of the blockchain, get enforced automatically. So there's no need for managing contention because contention can't come up in the first place because the rules are baked in. So blockchain solves the issue of multi-party contention without having to involve a human. Trust is no longer needed to contentiously interact with a third party. And this is the first ever instance of a technology which can do such a thing. And this is why we believe blockchain is such a game changer to the way how society, how business, how economics works so far. So yeah, I mean, that's kind of a very philosophical perspective on the blockchain, but what is it? So if you ask a computer scientist, you might get this answer: a Byzantine fault-tolerant, decentralized singleton, fixed-function state transition system, whatever that means. It's something like this, basically. Not this guy, but like what you see in the back. It's a really slow computer. So it's about 5 to 100 times slower than natively compiled code. It's really expensive to use, like this computer back then in the 60s or 50s. It's really expensive to store anything on a blockchain. And it's not always immediately decisive whether the transaction has finality. It can sometimes be reorganized, which is a bit different to some of the computer systems you're used to. However, it also has a lot of advantages because, I mean, otherwise, why would you use such a thing if it's so slow? It's a shared singleton, so it's a shared computer among many other computer users or computer systems that everybody can use and interact with. It cannot break down, cannot shut down, it can't be corrupted because it works in a distributed way in which it is very resilient to attacks or failures. There are many backups, many nodes on the internet widely that support this system. It's ubiquitous. You don't need special hardware. You can just like download the software on a normal PC and start using it. I mean, I don't know, does somebody own Bitcoin? Okay, so you know how a Bitcoin transaction probably works, what you do. So you don't need anything special for interacting with the system. And a very important thing, I think, for the finance sector, it's verifiable and auditable. So by means of cryptography, we have a strong mechanism for checking transactions, the validity of transactions, and making sure that what we believe is the history is indeed the history. And it can't be faked. I mean, at least not until, I mean, people are talking about quantum computing as means of attacks, but there are even ways to circumvent that if that happens. But so far, it's the strongest mechanism we have as a technology for ensuring auditability and verifiability of transactions. So what is Bitcoin? So if Bitcoin were a machine, it would be just an adding machine, basically. So it would be a very, very basic calculator in the end, where you can send or just add, basically, or subtract from an account. So adding, subtracting machine, both. I've been part, as I said, of a project called Ethereum. People call this a second generation blockchain because what it did was abstracting some of the workings of the blockchain and made it thus much more useful or much more versatile for other applications as well. So in this way, it's a very general computer, actually. So not just this very basic early calculator, but a general computer where I can upload any sort of program. And then many of you might have heard this really, really elusive term, smart contract. So in this perspective I'm giving you, a smart contract is just a computer program that you can upload to a blockchain and run there, make it accessible to other users as well. So that's what a blockchain is, roughly. That's what we think we built when we started the Ethereum project. But why? I mean, why is this so important? So being this ubiquitous singleton, it's just an innovation turbocharger because you don't have to go to like everybody individually, you know, when you want to launch a new system. Because it is this system that's just running on the internet and everybody can use, it's much more suitable for innovation than compared to connection for silos. I mean, some of you might be aware of what's going on in the European Union with the payments initiative, like the PS2 directive, and how cumbersome and like how horrible all these processes is to agree on standards, while with such a system you just have, by design of the system, a secure environment that everybody can use and interact with. So what we basically have these days are walled gardens. So interoperability is difficult. There are many barriers, multi-domain systems. It's on a technical level horrible to manage. It's very cumbersome, servers are expensive, while blockchain is always on and always ready. And not to mention security, which many people think is one of the biggest threats to society, like cyber security, as people call it, in the future. And people are working on using blockchain for improving security on the internet because you have such strong cryptography, such strong authenticity and auditability. This could be applied in many different circumstances where current centralized server architecture just leads to single points of failures that can be easy to attack. Basically, with a blockchain, unauthorized interactions are impossible, and that's what makes this technology so strong. Yeah, this is kind of the positive side of things. But where are we actually? I mean, there's so much hype, like so many new press releases every day, like things are sometimes a bit crazy. So there are problems that need to be solved, or I wouldn't call it problems, but it's just the way where we are at the moment, where the stage of the technology is. So at the moment, the way what makes this model so strong, this mining, what you have heard about, it's very difficult to scale out. So people are working on other ways for managing the security in a blockchain. For most blockchains, or like kind of true blockchains, public blockchains, everything is public. Everybody can see all transactions. Not necessarily can you give a meaning to it, because it's just a number, like the account isn't related to a real world identity. But in principle, you can see all moving Bitcoins, all moving Ether, all the operations in the smart contracts can be seen by everyone. And also, it's kind of and many people who've been following the space, there's kind of this one-chain model, which is not inclusive. So there are the Bitcoin maximalists who think like Bitcoin is the only thing you need, and we can make this like the system that everybody interacts with. But I don't believe so. I think the future is going to look a bit different. So yeah, as I said, security can't be scaled out. So one thing we are working on is exactly that in our company. If you alter what is called this consensus mechanism, like the way how you come to this agreement over the state of the world, namely by splitting what is called finality and validity, there are ways of scaling this out. It was one thing which was baked together in the early days of Bitcoin, just because it was basically a proof of concept. I mean, it was the first system, so you can't expect that this is like a already super scalable thing. Everything is public, so there are also ways to work around that. If you allow smart contracts to basically control parts of the code in a private fashion, which is very useful, obviously, for business. There are other ways of doing ring signatures and ZK snarks, so zero knowledge proof is a technology that often comes up in relation to blockchains, which allows you to do the transaction itself in a private fashion. So a very prominent project that tries to do this is called Zcash, Zero Cash, where they basically took Bitcoin and introduced this way of zero knowledge proof, so they can run a perfectly anonymous blockchain. For some people, it's like a horrible thing because, like, oh, now you can like pay for drugs and weapons like completely anonymously on the web. But I mean, in the essence, like if you don't start with a perfectly private system and then selectively introduce transparency, I believe you never can come up with a secure system. And the one-chain model, as I said, is not inclusive. Like, I mean, I think the future will look a bit more like this, like many, many dots which represent the different blockchains. A very first step towards that was what you might have come across as the discussion between permission or private blockchains and permissionless public blockchains, which is kind of a bit similar to the intranet-internet discussion we've heard, or we were part of. I mean, I not, basically, but some people might have been part of this discussion some years ago. So intranets being faster, managed upkeep, private membership, more trust-bound, like a notion of legality often because you give permission, while the public blockchain is relatively slow because of the way how security is managed. There's public ownership. It's open and transparent, which is a good thing, but also in some cases a bad thing. It's completely trust-free, and I would argue it's something which we call these days illegal. There's no way, basically, of introducing a notion, or like, you can't it's like trying to say, oh, the gravitational constant is not 9.81 in the metric system, but like 20. Like in this way, I sometimes feel when regulators talk about the blockchain, or not just regulators or people who are like against the blockchain, they kind of try to impose their will on the way how this technology works. But I mean, technology is technology. You can't change some fundamental principles. And that's why we kind of call it an illegal system. So there is this notion of legality doesn't make sense. So basically, one thing we are working towards now is is what I said, this system of multiple blockchains that can interact with each other, like different public blockchains suited for specific purposes, like Bitcoin for payments, Ethereum for general computations, like verification of ID, tracking of stuff, IoT, what have you. And then private blockchains where consortia just interact with each other, and that hopefully then in the future can also talk to the public chains. And we call this project Polkadot. I just want to run through, so you get a sense of where, I mean, I don't expect you to understand all the details I'm talking about now, but I just want to I want to help you get a sense of where things are going and where we are. That's why I put this part in. So, as I said, this abstraction between validity and finality can be used to pool security. So what these blockchains will all do is they will share like sort of a mining pool that checks the finalization, or is like responsible for the finalizations. But for example, the institutions themselves, which run private blockchains, could still be in charge of the validity. But sharing the security has a big advantage for scaling this out. And there could be trust-free interactions between the chains, which is at the moment not possible. So you can't transfer Bitcoin to the Ethereum chain, you can't transfer Bitcoin to a private chain. Like all this magic that people think blockchains could be so useful for is something the technology just can't provide at the moment. So there'll be relay chains, para chains, that's what we call it. They'll interact with each other. You can transfer between all these chains. And all this is part of what we call this Polkadot network. So where are we? So in 2008, Bitcoin was released. 2013, some of you might have read about this. It hit the so far highest market cap of $15 billion. 2014, essentially 6 years after Bitcoin came along, people had been playing with the model quite a bit, and Ethereum was launched as an idea of generalizing the Bitcoin blockchain concept. Funded an 18 million crowd sale based on a blockchain, so without an intermediary. People raised 18 million, or we raised $18 million of crowd sale money. We released the blockchain in 2015. That was about the same time the banking sector became much more aware of it. R3 was launched. IBM Hyperledger started their first marketing initiatives. 2016, last year, some of you might have read about this DAO, the Decentralized Autonomous Organization. So one thing that people have imagined as kind of a new instance of this new model. Like, you don't have a central organization that's like governed by a single party, but like a decentral way of interacting with each other and of managing a big fund, basically, to finance projects. So this was a $150 million fund back then on the market value, but it was unfortunately hacked because this smart contract, this computer program that somebody uploaded had a bug. 2017, like we recently saw Ethereum hitting a 4 billion market cap, and a lot of what people call ICOs, like initial coin offerings. The coin being basically the mechanism for making these decentralized organizations work. And Zug is a very prominent place for this, so many of these ICOs legally are anchored in the canton of Zug. So what does this mean short term, like for practitioners? It's a lot of like cost cutting, like robotics for manufacturing, a lot of automation that can happen, a lot of back office that can probably be made redundant. Short-term talking points, happy days for security, business process programmers, as I would call them. But sad times for people that manage processes, for process execution, oversight, like tedious audits, paperwork. It's probably something we'll soon won't have to deal with anymore. But then in the long future, there's something I tend to call now automation. So not just automation, but systems that have a certain autonomy with these rules baked in that can't be changed just at will, which I think is what will affect, in the long run, the financial sector, because it effectively these days runs on SaaS plus trust, and the blockchain will automate this trust to a large extent. So it will lead to disintermediation and obsolescence. I mean, to a certain extent, a level playing field. That's how you could also think about disintermediation. And the question is, which functions are left and can they be monetized? So I think that's the essential question you need to ask yourself. What's your business proposition? What's your value proposition? Is it just because you got this authority and that's what you can basically exploit? Or do you have a different value proposition? You have good analytics, good risk management, what have you. So for the financial sector, I mean, for McKinsey, I've done several projects in banks as well. I mean, I think inertia will be extremely high. Regulators will have their say. I mean, introducing big software projects takes ages for big institutions. And overcoming will take a while. So, and standards and security will remain two big concerns. So probably 5 years before major production cases, 10 to 15 years before for longer term effects are really, really felt to the system. Which doesn't mean that for other industries that could be way faster, and I believe so. Thank you.
Thank you very much. Interesting topic. Do you have any questions now? Because I think there are a lot of questions about blockchain here. We have afterwards a panel discussion where we can discuss some points, but now your question.
I have a question. You mention, and much of that literature mentions, completely trust-free systems. Mm-hmm. Now, and very often this is used in relation to Bitcoin, for instance. I wonder whether a trust-free system can ever be operated, at least in the short term, because even with a system like Bitcoin, you have to trust the computer program itself. You have to trust the Bitcoin organization or whoever is running the system and has the authority to modify it. And if you're a user, you have to trust the intermediaries, which, I mean, it's all part of, maybe the system is in itself, it doesn't require trust, but as soon as it contacts with the rest of the world, it does require trust. It requires wallets, it requires exchanges, and so on. Now, and I wonder whether you could add a word about, in this context, the contrast between permissioned and non-permissioned systems.
Let me maybe separate this into two parts. So let's talk first just about the blockchain and trust-freeness. So I would argue it is indeed a trust-free, or like at least very, very, very low trust system. So I don't have to trust the computer program because it's open. It's an open source system. I can check the code myself. I can download it. I can compile it on my computer system. I don't have to use executables that I don't know what they do. Of course, I mean, if I'm not a programmer, I might need to go to someone like the Electronic Frontiers Foundation or like somebody else I trust to check the code, but it's possible to check it, which is not possible for banking systems at the moment. So, and likewise, the running of the system, like everybody can participate in the maintenance and the curation of the Bitcoin blockchain. Everybody who has compute power can verify and become a validator themselves. So you don't have to trust that there is no blockchain organization or Bitcoin organization.
But you have now this problem of forking.
You have the problem of?
How the problem of forking.
Sure, there is a problem
that there must be somebody who decides, or there must be some decision at some point.
There's one big problem that I haven't talked about so much, which is often called the problem of governance of decentralized system, and we haven't figured that out yet, how to do this in a good way. I mean, there was a fork after the DAO attack that you might have heard about. So a fork meaning afterwards, like people needed to change something in the system because of this DAO hack, and some people who used it were unhappy with it, so they wanted to run the original system, so to speak. So now we have two Ethereums. There's an Ethereum and an Ethereum Classic, and there were quite a few very religious fights about what's the right one and whether this exists. But there are propositions for solving this, like ways of also baking in the governance into the system, so people, the stakeholders basically could vote which version they want to run or which changes they want to adapt. But it is a big thing that needs to be solved. And in this context, private blockchains could be helpful if you are very concerned about your governance and you are actually quite in good agreement. You have like a semi-trusted environment where people want to run this way, this consortium in this way, then a private blockchain could be very useful, which hopefully in the future can talk to a public chain. But in this private chain, you have like strong governance in that sense.
Just one other question, then we have to go on.
What's your thought? When will this be introduced into the banking world in a broad sentence?
I don't know. I mean, I think it's good, like as a lower bound, to just look at bigger other backend software changes like IBAN or like what we've seen recently. I mean, this took years and there were many delays just for the introduction because this old system is so cumbersome, like grown over years and years and years. So it's difficult to replace hardware, like backend software that people have been relying on, backend systems. I don't know. I mean, I think it's more likely, like if we get friendly regulatory environments, that it indeed creates a level playing field where people can innovate. And once we see something like a stable coin on top of a blockchain, like a stable currency that can be run, it's a super open system where people could run their own bank. So.
Okay. So. Last question would be, do we, in this new, wonderful new world, still need banks?
I think that's not up to me to...
Okay, because it gives me a very good point to come to the next speech. But thank you very much for being with us, and we can discuss this in the afternoon.